Chapter 16, Troubleshooting and Servicing the PLC System. Objectives are to explain the meaning of MicroLogix PLC indicator lights, use force instructions to check PLC input and output, use PLC programming software to find CPU fault errors, take corrective actions to correct the fault errors. Routine maintenance. Indicator lights should be monitored to check the condition of an operating PLC unit. Be surprised how many times I've seen people, it's not working, it won't do anything, and that run light is turned off. That means that your controller is not in run mode, and if it's not in run mode, it's not going to process any logic. Not processing any logic, you're not going to update any outputs. I'm not pushing the button and I'm seeing the thing change. Well, controller's not running. Power light should normally be on. If it's not on, check the blown fuse, trip circuit breaker, open circuit in the supply circuit. Check voltage at the power supply, and check for proper power supply jumper connections. Check output voltage of the power supply for correct DC voltage levels. 2 and 3 on there are for the old slick controllers. You can't do those on the MicroLogix. Make sure that the controller has power applied to it, but it in itself doesn't have its own power supply. So the run light is on when the processor is in run mode. It was expected to be on and it's not. Check to make sure that it's actually in run mode. Make sure it doesn't have a fault. And check for short circuit input output modules or improper grounding. Fault light indicates when the processor detects an error in the ladder diagram. When the fault light turns on, connect the laptop or PC to the PLC. Read the error message displayed on the screen. If the controller is in fact faulted and the fault light is on, when you connect to it, instead of remote run or remote program or whatever, it will say faulted and be bright red. You can click on that and select go to error, and it'll take you straight into the status page on the fault screen, and you can read what fault is there. Click status file 2, find the error flags. Clear the error. If the fault condition persists, disconnect power to the PLC and replace memory module. Won't necessarily fix it. What that should say is figure out what caused the fault, fix it, then clear the error, and try to start back up. If you're doing something stupid in the program like divide by 0, and you failed to put the OTU overflow track instruction, last thing in your main program, divide by 0 will fault your controller every time. Force IO turns on when the processor is in a force condition. Force is to be used very sparingly, very intentionally, and whatever you do, don't leave an input or an output in a forced condition and put the processor back into production, because people tend to get hurt that way. It's also an OSHA violation. Those can get really expensive really quick. If you as a technician force an input or an output, somebody gets hurt, you can be held personally liable. So it is a big deal. Programmer can close or open inputs, tell the controller that they're either open or closed. Turn outputs on or off by using computer keystrokes. Programmer use to check the input and output ports, sometimes used for troubleshooting the ladder diagram. Must be used with extreme caution. OSHA regulations require that technicians must not use during normal plant operation. Only during plant shutdown periods, since unexpected starting or stopping can injure plant workers or you. Motherboard battery and battery low indicator. The battery low indicator, which is located on the LCD screen on the MicroLogix controller, turns on when the battery is detected to have below, whatever threshold of voltage on it. Tells you that the controller or the battery on the controller needs to be replaced. Motherboard battery, there again, that is a slick thing. MicroLogix doesn't have that. Uses the external battery for both. One important thing about the battery, you must leave the power on the controller when you disconnect the battery. If you have the power turned off, you disconnect the battery, you will lose the user program. So always make sure you have the battery or the controller power on before you disconnect the battery to replace it. So you don't have to break out the laptop and read down. Hopefully you have backups for all your programs, but never know. Environmental maintenance, you want to make sure that the environment is clean around the cabinet, inside the cabinet. Make sure that the door stays closed and that sort of thing. If there is a fan or air conditioner on that enclosure, you want to make sure that you regularly check and clean or replace any filters that are on so that they can continue to have proper ventilation. If the enclosure itself gets too dirty, it won't be able to dissipate heat like it's supposed to. It'll also cause it to heat up, do bad things to the stuff that's inside of it. Hardware. PLC devices usually have input-output status indicator lights on their I/O modules. The MicroLogix slot 0, the I/O is on the LCD screen, and then any expansion module, the LEDs are on the module itself. You can use those to monitor the operation of the PLC. All it's really going to tell you is that it's either getting an input or not, and it's turning on an output or not. It doesn't mean that the program is actually working the way it's supposed to. MicroLogix has 20 inputs, 0 through 19, 12 outputs, 0 through 11. That's the LCD screen for slot 0. So these are the inputs, these are the outputs. So 1, 0, 1, 2, 3, blah, 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 blah. This is actually 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it's 0, 1, 2, 3, 4, and so on, 14, 15, 16, 17, 18, 19, and then the outputs are just 0 through 11. These guys up here, that's the battery low indicator on MicroLogix. These are comm channels, and those two are almost never used. So. Expansion module always has indicator lights on it. That's these guys. If it's actually used, it'll have the LED. If not, it'll be basically a plug covering the hole. It's the same color as the module itself. Ladder logic created by Logix 500. Force file icons and project tree. Have your data files, and then the force files are here. If you go into input and output data file, there's a button on there labeled forces. Click that and it'll change to the force display. So you don't have to use those specifically. Input force dialog box. Yeah. When you where it says data file here, if you were in the data file, as we say, forces, click that, goes into forces, and then changes that to data file. So you can toggle back and forth between the two. Forces must be enabled in order before they'll do anything. So you can install them and have them disabled, nothing will happen. If you enable them, that's when they take effect. On MicroLogix, you cannot enable and disable forces online. You have to enable or disable offline, recompile and re-download the program. You can install and remove online, but you cannot enable or disable online. Output forces dialog box looks exactly the same on these outputs. If there is a force installed and it's enabled, the indicator turns red. So it's kind of obvious that it's in a force condition. Software error detection, CPU fault light on the front of the controller is turned on. And there's an error in the operation of the ladder logic diagram. Diagnose the error, technician must connect laptop or PC, loaded with 500 software. PLC is placed online with the computer. And in the monitor mode, status file 2 box is opened up and you find and correct the errors. And that is what the dialog box looks like for the errors. And that's that.